Alright, and we're back. No music this time, sorry, but that's the way it goes sometimes. Alright, we're talking about amide groups. We talked about DEET, okay? Now we're going to talk about a carboxyl group, which basically is a double bond O and an OH group, okay? So if you have both of those on it, okay, if it was just this, it might be a keto or aldehyde if it had a hydrogen off here, but instead it has a hydroxide group or OH group, okay, and then has carbons going back this direction, then that is going to be an acid or organic acid. And so there are a lot of these, for example, acetic acid, okay, which is vinegar, okay, we're all familiar with that. The smell and taste of vinegar comes from this acetic acid. Some people like it, some people don't, but there you go. And there are other ones, I mean, so there's just different kinds of what we call organic acids. Now, if you remember back, we talked about acids. We said acids give off hydrogens. Well, when you put this in water, then this hydrogen comes off, and you have a plus hydrogen here, you have a negative charge there, and basically it becomes an acid because it donates a hydrogen. Even though OH, normally if the whole OH comes off, it would be a base, but instead the hydrogen comes off, and therefore it makes it an acid. So just clear that up real quick. All right. Now, once again though, if the hydrogen came off and something else joined up to it, so you have your double bond carbon with your carbons go back here, and now the hydrogen comes off, you have an O. If it hooks up to another carbon chain with carbon going this way, so now you have double bond oxygen and a single bond oxygen that hooks it onto another chain. This is very similar, okay? It's kind of like we combine something to an acid, and now we have an ester. Okay, now Esther, not talking about the Bible Esther, Queen Esther, who saved her people, blah, blah, blah. This is Esther, is a group of chemicals. Generally speaking, they're very good smelling. A lot of flavorings that we are put in our food and so forth come from this group. Okay, so if you have two acids joined to get to another carbon chain, then it would make these. Some of the flavorings are, for example, rum flavor, banana flavoring, orange flavor, apple flavoring, wintergreen flavor. All of these flavorings and smells and stuff that we add to things, candles and so forth, come from esters in this group. And so esters are very important for that reason. They're probably the main group that we have that. All right. And that's basically the groups that I want you to be able to identify. I'm sorry, one more up here. And you may have noticed this on some other things we already talked about, but you can combine groups. For example, this one is an ester because it has an oxygen and a double bond oxygen and another oxygen connecting to other carbons. Okay, but it also has a just double bond oxygen up here in an acid group. So this is actually an acid. It's acetylsalicylic acid, which we know as aspirin, and aspirin is an acid. Okay, we talked about that before. And so it's a combination of an acid group and an ester group, and that's what makes the pain reliever aspirin, which obviously is a very important thing in most of our lives at one point or another. Now, this is just a chart that shows the actual formula for these different esters. You see the double bond O and the O that connects them to some more carbons. And then over here, you see what the flavors are. We have ethyl formate, which is like, what? But rum. Okay, but isopentyl acetate, so ooh, that's gross, but that's actually banana flavor. And you still might say that's gross, depending if you like that or not. Very strong flavor. Acetyl acetate is orange. Methyl butyrate is apple, and methyl salicylate, which is wintergreen. Now, once again, I want to reiterate, I want you to be able, if I give you one of these and the chart showing what they are, I would like for you to be able to tell me that that is an ester. Okay, and so that's the kind of thing I really want to emphasize on these groups. Not that you memorize all of them. You need to know, like, esters are very important for flavorings. Alcohols, obviously, beer and wine have alcohol, but also rubbing alcohol, things like that. Just know some examples of them and what they do. But for the formulas, I just want, if I give you a formula and the chart, you can match them up where they belong. Besides the characteristics of these main groups, a lot of hydrocarbons, while they're so important, it has to do with plastics. And most of these plastics are what we call polymers. Okay, polymer, poly just means many. You've probably heard of polygons, which mean have many sides. Okay, and what it is, if we have some smaller units that we hook them together in long chains, and so we may have this one molecule. This may have thousands of atoms because you have all these different smaller compounds that get hooked together in this long chain. Okay, and when they start making these long chains, they allow them to stretch either one way or both ways. Others may have strands that go in three-dimensional, and so it kind of locks it in place and makes it very rigid. And so these are very often these plastics. If they allow stretching, then they're the soft, flexible plastics like saran wrap and plastic bags and stuff like this. If they're hard and rigid, then we use them for containers and water bottles and things like that, or different degrees of thicknesses and different degrees of hardness, and we can use them for all those things. And they're basically what we call polymers. Okay, so they're polymers which are made out of single units that are called monomers. You hook enough of those together, it makes a big polymer. All right, and so let's look at some examples of some of these. There are two main groups of these. There's ones that are just what we call addition polymers. Okay, addition polymers means you take a basic unit, all right, and you just add those basic units over and over again to make polymers. Okay, for example, styrene are little monomers. They're just made of two carbons, and then a carbon ring over here with some hydrogens off of it. Okay, but if you add all of these together, okay, so that the carbons just join up to each other, okay, you have the same unit over and over and over and over and over, just stuck in together, and you add them together into these long chains. And these long chains have the plastic properties that we like to use them for. And so that causes them to have these different properties. Now, plastics have a lot of abbreviations that they use to tell what they are. For example, this is high density polystyrene, okay, and this is HDPE, and then you have low density. And because of the differences in these, the HDPE, is very rigid, okay? It has straight strands, but this other one has branching, and so it's more flexible and can be used, okay? And so the rigid one is a lot used to rigid plastics like containers and brain went dead. Water bottles, not so much disposable water bottles, but the ones that have a harder plastic in it. These, on the other hand, might be used more for plastic bags and stuff like that. And if you look on it, usually there'll be a code on it that says HDPE or LDPE, and that's because it has to do with recycling. If you recycle them and know what kind they are, then you can sort them and reuse them over again. Okay. Styrene is another one we talked about. I had styrene up here. Styrene. They were experimenting with that, and it's kept foaming up, and the guy would kind of skim the foam off, kind of plop it over here on his lab desk, and eventually when the experiment was over, what he was trying to make, he looked at that foamy stuff after it hardened, and he said, hey, this is kind of neat stuff, and that's basically styrofoam. It was styrene, but then when it hardened, it became styrofoam, and then hey, that might be something we can use. And a lot of these things were like that. They were just experimenting with them, seeing what they could make, and then once they made something, is there something useful we can do with that? Okay, so as I got polystyrene, which would be just a bunch of styrene stuck together, is going to be the clear plastic cups that we use, would be an example. PVC is another, polyvinyl chlorine. Okay, would be another example of that we use for lots of different things. PVC, and notice you see here's the little code we talked about, HDPE and so forth, and these tell you what can be recycled and what cannot, and so forth. So if you look at these, polyvinyl PVC is generally, we think of pipes. I think of PVC pipes, etc. Okay, and that is very hard, rigid material, but there are chemicals that they can add to that called plasticizers. Okay, plasticize means to make plastic, okay, or make it bendable. And so PVC can also be used for things like shower curtains and things like that, okay. And some of these chemicals that they added were phthalates, okay, phthalates, That's one. Phthalates. Okay, phthalates. Not a P, T's, and TH's. They're all PH's and TH's all there. Phthalates, and some of these phthalates were shown to be dangerous. Okay, they would give off chemicals that harm the reproduction organs, especially in the fetus, unborn fetus, and in young children. And so they had to be removed. And so once again, plastics bring us a lot of great things, but then when we get new things like that, sometimes there's side effects, and we have to watch out for those sort of things also. So it can kind of go back and forth. Okay, so there's a lot of different ones. Saran wrap, for example. Saran wrap has chlorine atoms in it, and the chlorine atoms can cause a charge, okay, or an induced charge. So there's positive and negative charges. So when you put them on things, they want to cling. A lot of cling wraps, okay, cling things that you put on the glass, same kind of thing. They can create a charge, some slight electrical charge, and it causes them to kind of like static electricity. Those two charges are attracted to each other, and it sticks on the glass. All right. On the other hand, a very similar product is called Teflon. Okay, Teflon has fluorine, probably where the FL came from there, fluorine. Okay, and fluorine makes very strong bonds, but it does not make these charges, so things do not stick to it. And that is why it is, one, it can be heated, used in pans and stuff, because it doesn't mind getting heated, doesn't melt like saran wrap obviously would. Okay, but the fluorine allows it to be non-sticky, and nothing sticks to it at all, because you can't induce a charge in the Teflon, and it won't stick, and there is no static electricity or anything, and so nothing tends to want to stick to it. And of course, that's very famous as Teflon pans and things like that. Also, some presidents, I think it was Reagan, everybody called the Teflon president because all the people in his office got in trouble, but it never really stuck to him, and everybody liked him. All right. All right. Now, there's another type of polymerization, which is called condensation. Polymerization, okay? And in this case, these polymers are where you have two chemicals, like here's an NH2 group, the amine, and you have an OH group. And if you take one of the H's here, or the oxygen and the two H's here, you can make water, and then you can use the remaining hydrogen to hook together these two chains, okay, or the nitrogen to hook together the two chains. All right, and you can keep doing that over and over and over again, and you make water off. So that's why it's called a condensation, because you're creating or condensing water. Water shows up at the end of it, okay, and therefore, and some of the important ones that are formed by this one are nylon, okay. Nylon hose replaced silk stockings during World War II and was a really big thing. Nylon's used in a lot of things now, clothing, etc., and so forth. PET plastics, they are used for bottles primarily, but they have also been used in clothing. In clothing, they don't want to call it the same thing because it might sound like you're wearing bottles, so they put Dacron. Okay, it's called Dacron, but if you hear Dacron, that's the same thing as the PET or PET plastics that are in most disposable water bottles and so forth like that. And so they can actually recycle water bottles and use it to make shirts. You may see that occasionally where they advertise a shirt that was made from basically plastic bottles. All right, Mylar is when they can put long, thin sheets of plastic. These would be like the balloons, silver balloons, the helium balloons that they have, and things like that. They're made out of Mylar. Thermoset plastics. Now, these plastics, as they get hot, are going to melt and change shape, a lot of the plastics we talked about. But there are what are called thermoset plastics, which means once they're heated and molded to a certain shape, they will not change that shape. They won't, when you heat them again, they'll stay rigid and they do not bend. And this has to do with, like we said, instead of just chain bonding or maybe branching off, you have some really rigid 3D bonds that make like a lattice, and it will not let the plastic change shape. It's a stiff, rigid thing. Some of the things that do this, Bakelite used to be one of the first plastics, a lot of usually beigeish old radios and stuff you'll see made out of this color. Bakelite was real common. Now you Formica, like in Formica cabinets, things like that. There's something called Malmac, which is used for hard dishes and so forth. A lot of your microwavable dishes and stuff are going to be made out of these kind of hard plastics. All right. A lot of incredible changes have come because of plastics. There's also some dangers with it. Plastics can release certain chemicals and stuff, so we have to be on the lookout for that. But they already have polymers that conduct electricity. You don't think about plastic as being able to do that, but they can. Some that give off light. Some can be used to replace body parts. We've already seen a lot of plastics replacing metal parts in cars and stuff like that. Some of these are very strong, even stronger than steel, and therefore you don't sacrifice the strength, but you do get more weight. Some can actually take solar energy and create chemical energy, some kind of similar to what plants do. And there are some that can change salt water into fresh water. Okay, so these are not obviously ones that you've seen for sale at the store.